right, so this is chapter 10, section 2, parabolas. Our learning objective is to write the equation of a parabola and graph parabolas. Now we've been kind of hopping around parabolas for the past couple of years in math, and now we're going to really identify the particulars of it. So each point of a parabola is equidistant from a point called the focus and a line called the directrix. So if you look at, here are the parabolas we've been dealing with in algebra and geometry. This is a vertical parabola. The focus is a point inside the curve of the parabola, and the directrix is a line on the outside of the curve of the parabola. And the parabola, if you map out the distance between the directrix and the focus, ends up, each point on the parabola ends up being equidistant from the focus and directrix. So our key concept is that a parabola is a set of all points in a plane that are the same distance from a fixed line and a fixed point not on the line. That's the stuff right here. Same distance from a fixed line and a fixed point not on the line. The fixed point is called the focus of the parabola. The fixed line is called the directrix. And the distance between the vertex and the focus is the focal length. One of the differences we're going to find in this is the horizontal parabola, which is really similar to the vertical parabola, just rotated 90 degrees, but it changes the equations that we're going to use for the directrix, the focus, and the axis of symmetry. So in this scenario, the picture of this parabola is a vertical parabola, and for a vertical parabola, the parent function is y equals ax squared, and a is equal to 1/4 c. The directrix is y equals -c, and the focus is at 0, c. So if you are given the directrix or the focus, you can find the equation of your vertical function. So, and that's what's going to happen here. So it says, what is the equation of a parabola with a vertex? And let's just draw the picture so we can. The vertex is at 0, 0. And the focus is at 0, -5. Put some grid marks on my graph. Oh, and negative. I'm going to mark the focus with an F, 0 and -1.5. And so, you look, we open around the focus, because the focus is like our precious little treasure. We open around it. We just want to give it a nice little hug with our parabola arms. So when we put the equation together, if you look, the focus is at 0, c, and in this case, c is -1.5. So now I use that. If a is equal to 1/4 c, then I know it's 1/4 times -1.5 And that gives us A is equal to negative 1/6. So my equation is y equals negative 1/6 x squared. Okay. So now let's take the opposite scenario where we have the equation and we need to find the vertex, focus, and directrix. So here's our equation. We're going to pull out the vertex, the focus, and the directrix. So I'm going to rewrite this equation a little bit. I'm going to say that it's y equals 1/4 x squared. That way I have x squared by itself, and I know A is 1/4. So I'm going to take our little equation. A equals 1/4c. And I'm going to say the A value here is going to be 1/4. So 1/4 is equal to 1/4 times c. And just for fun, you can solve this in whatever way makes sense to you. You can flip both denominators. You can multiply by 4c to both sides. In this case, I'm going to cross multiply because I find that students love cross multiplying. So we get 1 times 4c, and we get 1 times 4. If 4 times c is equal to 4, c must equal 1. Okay, so now we know what c is. We can find the directrix. Let's find the vertex first. So in this case, because I have no h or k, I have a vertex of 0, 0. When we did parabolas before, we had y equals a times x minus h squared plus k, where h and k were the vertex. In this case, because I have nothing being added or subtracted, I have a vertex of 0. The focus is over here. It is 0, c. So because I have c is equal to 1, the focus is going to be at 0, 1. And the directrix is at y equals negative c. So the directrix is going to be y equals negative c. And I did sniff the answer. So the answer to 1a is y equals negative 1/6 x squared. We got that. The vertex for b is 0, 0. Focus is 0, 1. And the directrix is y equals negative 1. And then the answer to how does the distance of the focus from the vertex affect the shape of the parabola? As the distance between the vertex and the focus increases, the width of the parabola increases. So when the distance between vertex and the focus is big, you get a nice wide fat parabola. Good times. And then the smaller it is, so the smaller it is, the more narrow your parabola gets. The bigger it is, the fatter. So a big difference between focus and directrix will be a nice fat parabola. Now, we're going to look at, what we did before was the vertical parabola. Now we're going to do horizontal parabola. So we're going to look at it like, here's x and y. We're going to have a focus and a directrix that create a sideways parabola. And the parent function for the horizontal parabola is x equals 1/4 c y squared. See what happened? The x and the y, they switched. Everything else is still same. So in this scenario, you say, what is the rules still apply. Where our a value is still 1/4c, our focus is at c comma 0, and our directrix is at x equals -c. Similar, not different. So in A, we know that the directrix is x equals -5 halves. So if that's the case, then the focus needs to be at 5 halves 0. And if that's the case, then our equation is 1/4 times 5 halves y squared. If x is equal to 1/5 halves y squared, let's simplify that to 1/10 y squared. Let's do B together. What are the vertex, focus, and directrix of a parabola with the equation x equals -4y squared? So in this scenario, a is equal to -4. We know that 1/4c is equal to a. So now we need to solve for c, and I'm just going to cross multiply again. So 1 times 1 is 1. 4c times -4 is -8c. Divide both sides by -8, and I get c is equal to -1. So we want the vertex. Vertex is easy because it doesn't have the plus or minus in the equation, so we know that the vertex is always going to be at 0, 0. The focus is at c comma 0, so here c is -1, 8, comma 0. And the directrix, abbreviate that DIR, it is x equals -c, so it's -1/8, so that's 1/8. All right, let's summarize. And in our summary, we're also going to, would like you guys to include a picture. So, let's do it on the side. So we've got two different types of parabolas, which is going to be different than what we were doing before. the vertical parabola when you know your vertex is at 0, 0, has an equation of y equals 1 over 4c x squared. The focus is at 0, comma c. The directrix is at y equals negative c. And it only changes a little bit when you move the vertex. So a vertical parabola is like the ones we've been doing before. They're either going to be smiley face or frowny face. The horizontal parabolas, when the only difference between the two is the x and the y switch. So when you look at x and y, they've switched from when they were up here. So on the vertical parabola, y equals 1/4 c x squared, and on the horizontal parabola, x equals 1/4 c x squared. And this one will either open to the right if a is positive, or it'll open to the left if b is negative. Okay, so we're going to take this nice little quadratic equation and find the vertex, focus, and directrix. So remember when we worked on completing the square, and that was fun? Okay, so we're going to bring that back a little bit. So we're going to look at this as, we're going to complete the square here. We're going to put 418 over here. We're kicking them out of the, whatever number we pick to complete the square, we're going to subtract it off the end to make sure we're keeping our equation equal. So to complete the square, we take our b value, we cut it in half, and we square it. So that's 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 here, and we're going to take it away here. And when we do, a magic thing happens. We get the perfect square, x plus 4 times x plus 4. And then 18 minus 16 is positive 2. So when we take this equation and we compare it to the vertical parabola where I have y equals and I have an x squared. So I'm going to compare this equation to this equation right here, and I'm going to pull out my vertex, focus, and directrix. So right next to this one, I'm going to write y equals 1/4 c x minus h squared plus k. Do a little side-by-side comparison. When I do, I know my vertex is at opposite of what's inside, negative 4. And my k value is 2. I'm going to go up here for my focus, h. So if we want the focus, it's going to be at h, comma, k plus c. So I know h and k, it's negative 4 and 2. I don't know the c, so I'm going to find c. So I do know that 1/4c is equal to 1. When there's no number in front of the parentheses, it's equal to 1. Oops, you write it so that I can solve it. So once again, I'm going to cross multiply. So 1 is equal to 4c. Divide both sides by 4. C is equal to 1/4. So now I have my focus is equal to h, comma, k, which we found was 2, plus 1/4. Can't leave it as 2 plus 1/4, so we're going to write that as 2 and 1/4. And if C is equal to 1/4, my directrix is going to be y equals k, which was 2, minus c. And we simplify that to y equals 2 minus 1/4 is 1 3/4. Okay, so last question. What is an equation of a parabola with a vertex of 1, 4? And a focus of 1, 6. So I'm going to draw a picture of this, because it's always better to have a good, is this a vertical or is this horizontal? And I'm a visual person, so I prefer to have a nice picture to go by. Alright, so if my vertex is at 1, 4, that's right here. And my focus is at 1, 6. And remember, our parabola hugs our focus, so he is going to go up. So he is a vertical, so he's our classic y equals 1/4c x minus h squared plus k. We know that h is 1 and k is 4. And the only thing we don't know is the c, so let's go up here. We know that in a vertical parabola, the focus is at h, k plus c. So this is h, k plus c. And we know that k plus c is equal to 6. We know k is 4. So 4 plus c is equal to 6. C has to equal 2. So now I can plug in 2 to my equation. So this is y equals 1/8 x minus 1 squared plus 1.